This lesson we're talking about angles that exceed 90 degrees or angles of any magnitude, any size. Now this is all based on our unit circle here on a Cartesian plane. If we go and create a right angled triangle here, and we're actually going to go create the same right angled triangle 4 times. So one we're going to reflect in the y-axis, one we're going to reflect in the x-axis, and then the other we're going to reflect in the x and y-axis, or we're going to rotate 180 degrees. So we end up with something like that for our triangles. Pardon my crude drawings there. But the thing we've got here is all these angles here in these triangles are theta. Now what I've created here is four congruent triangles. But what I have done, in fact, I have flipped them in different directions. So their x and y coordinates are different, which means we're going to end up with different values here. Now in our first quadrant, both x and y are positive, which is why A for all trig ratios in the first quadrant are positive. In the second quadrant though, I've got my x value is negative, but my y value is positive, which means that when I go and find my value for sine using the opposite, which is here, my y value. So in our triangle here, failed to mention this, but we end up with sine theta in all of our triangles. Sine theta equals y over 1 being the unit of the unit circle. So sine theta equals y. In the same way, cosine theta equals x, the adjacent, over 1, and tan theta equals the opposite, y, over the adjacent x. So, using those things here, when y is negative, sine is going to be negative. That's these two down here, okay? That's these two quadrants down here. That's where sine is going to be negative because y is negative. In the same way, when x is negative, cosine is going to be negative. That's these two here, okay? Now, where both of them are negative, where both x and y are negative, we actually get a doubling off effect for tangent, which is why down here, tangent is positive because we have a negative x and a negative y over a negative x. And the ones I'm not describing here as positive are negative as well, except in the first quadrant because everything is positive in the first quadrant. We have positive y values and positive x values in that first quadrant. Okay, so that's how we end up with this ASTC, all stations to central, is the way I learned it when I was your age. But there are lots of different mnemonics as to how to remember that. The other thing to look at here is how we find those acute, the related angle in each quadrant. Well, if we start with some acute angle theta in our triangle, and now theta is an acute angle here. It exists in the first quadrant. Now what we want to find is what's the equivalent angle here in the second quadrant. Well, that angle there, if we look at our angle theta here, well, to find what all the rest of this angle is, we're going to take away that acute angle from 180 degrees, which is this statement here. Just saying that to find the value of an angle in the second quadrant, we're going to take it away from 180 degrees. In the same way, in the third quadrant, we're going to travel 180 degrees already, plus another theta. So that's how we end up with 180 plus theta in the third quadrant. And in the fourth quadrant, we can actually do, rather than going up to reach our line, we can actually go backwards, which is we take our full revolution, 360 degrees, and come back 30 degrees. Sorry, theta degrees, not 30 degrees. Could be 30 degrees, but it's theta degrees. In fact, if we do take that angle of 30 degrees here, if we said theta was 30 degrees, well, we know that sine 30 is equal to a half. So in the second quadrant, the angle related to 30 in the second quadrant, we go 180 minus 30, which is 150. So sine of 150 is equal to a half as well. Positive a half because the second quadrant sine is positive. Now in the third quadrant, we take 180 degrees and add 30 degrees. So we'd have sine of 210. But this time, our value would be a half, but in fact it would be negative. Okay, because we moved into one of our two quadrants where sine is negative. Same deal in the fourth quadrant. Sine of 330 degrees by moving 30 degrees backwards, 360 minus 30, would give me negative a half as well. And you can go check those in your calculator. You can choose some of the other exact values if you'd like. You can choose a non-exact value, 17 degrees if you'd like, and go confirm that there's a relationship between how these angles work in the four different quadrants. And they'll give you the same absolute answer, but some will be positive and some will be negative depending on which quadrant and which ratio. Let's have a look at an example here where we're given a couple of pieces of information and we need to go and find a third and fourth piece of information here. So we're told that if tan theta equals 3/4 and cosine theta is less than 0, we need to find sine theta and cosine theta as fractions. We do have enough information to do this, and it's not by going and finding our angle. We could do that, but that will not give us exact answers, so that's not what we want here. So what I'm going to do is a very basic right angled triangle, which is really going to prove quite helpful for us. Now, what we do know is that we know this angle, let's call this angle here theta. We do know that tan of theta is 3/4. Now, we could go find what theta is there, but I don't want to. But what I instead want to do is I want to say that tan theta is the opposite over the adjacent. So that means this length here is 3 and this length here is 4. Now, we actually then can go find out value for h by saying h squared equals 3 squared plus 4 squared, which is 25, which means our hypotenuse is 5. So 3, 4, 5 Pythagorean triad. I'll give you the most basic triad we can deal with. Now, the other piece of information we're given is that cosine theta is negative. So what we've got here in our all stations to central, all positive sine, tan, and cosine positive in the second, third, and fourth quadrants respectively, what we're told is that we know that tan theta is positive. So that means I can eliminate these two quadrants. Okay? My trigonometric ratios are not going to be in those two quadrants because tan theta is not going to be positive in those. I also know that cosine theta is negative, which means I can't be in quadrant 1. I could be in quadrant 2, but our first statement of tan theta being positive eliminated me from that quadrant, which means I have to be in quadrant 3, okay, which is going to tell me something about sine theta and cosine theta. We already knew cosine theta was going to be negative, but now we've also confirmed that sine theta will be negative as well. Using our triangle here, and we'll get rid of that h and call it 5, because we've found that now. I'm going to say that sine theta is equal to our opposite 3/5, that being negative, of course. Now that's not because that happens when we go and put this triangle onto a Cartesian plane. Drawn as it is there, well, we can't have a length of -3, but when we put it on a Cartesian plane, we end up with a negative value for y, which means we can have a negative in our ratio. In the same way, cosine theta is our adjacent 4/5, our hypotenuse, and it is negative as well. So both sine and cosine are negative, owing to the fact that we're in the third quadrant. Combining exact values here and angles of any magnitude, we have 4 of these to do. And each of them is going to involve me turning this back into an acute angle, and then going and finding whether my ratio is positive or negative. So there's a couple of questions we have to ask ourselves here. First question is, which quadrant am I located in? And based on that quadrant, how do I go back and find my acute angle? And once I've done that in that quadrant that I was in, am I positive or am I negative? So tan 225, that puts me in quadrant 3. Okay, so to find my acute angle, my acute angle, I take away, I take 225 and subtract 180 degrees. So that means my acute angle is 45 degrees. Now I need to take tan 45, and I'm going to say tan 45 is 1, but our value here, we need to consider whether it stays as positive or becomes negative. Well, in quadrant 3, tan is positive, so in fact, tan 225 will just remain as positive 1 because we are in a quadrant where tangent is positive. Having a look again here at cosine 315. Well, now I'm in quadrant 4. Okay, so in quadrant 4, I'm going to say my acute angle theta is 360 minus 315. That's the one where I'm working backwards from a full 360, which gives me 45 degrees again. And so we need to find our exact value for cosine 45. So cosine 45 is equal to 1 over root 2. Combining those couple of pieces of information here, our exact value for cosine of 315, is going to be 1 over root 2. Again, we need to ask ourselves, will that remain positive or should that become a negative? And our answer is that it should remain positive because we're in quadrant 4 where cosine is positive. Having a look at the next two, tan of 300. Okay, so 300 degrees puts me in quadrant 4. And to go find my acute angle from quadrant 4, I'm going to say 360 minus 300. So the related angle I'm looking at is 60 degrees. So tan 60 is root 3. Now we need to ask ourselves, should my value for tan of 300 then is going to be root 3, but should that be positive root 3 or negative root 3? Well, our answer is that it should be negative because we're in the cosine quadrant, the fourth quadrant, where cosine is positive, but both sine and tangent are negative. So I end up with negative root 3 there. Sine of 150 degrees. Our first question we ask ourselves, well, I'm located in quadrant 2, which means to find my acute related angle, I take 150 degrees away from 180 degrees, which gives me 30. Now my value for sine 30, my exact value, is 1 over 2. So the question we ask ourselves to finish, my sine of 150, I know its absolute value is going to be 1 over 2. Should I leave it as a positive or switch it to a negative? Well, I leave it as positive because in quadrant 2, sine is positive. So there we've got a few questions that involve us finding the exact value of an angle that is bigger than 90 degrees. I hope this has been helpful.